In this lesson we're going to look at 3 dimensions, and particularly the coordinate system in 3 dimensions. Later on we're going to look at vectors in 3 dimensions as well. So it says here, in the real world, points in space can be located using a 3-dimensional coordinate system. If we think about coordinate grids, we're talking about anything in real life, we have to talk about 3D. You can see here flight navigation on our coordinate diagram. A flight or an air traffic controller wouldn't be able to view the planes and work out what was happening because they would all crash into each other. 2 planes could exist at the same point. If you didn't have 3D though, they couldn't, but in a 3D system one could be above the other instead of just having a flat kind of area to look at. But anyway, let's have a look at how this works. So 3-dimensional coordinates. We've been very used to X and Y axis throughout 1st to 4th year. We're now going to have the additional Z axis. So traditionally when you look at the coordinate grid, you've got X along and Y's up and down. In the 3D coordinate system, X is across and Y goes into the page, and Z is now going up. And the coordinate works the same way. We've still got brackets, except we've got 3 numbers instead of 2. The first number is your X coordinate, the second number is your Y as before, but the third number now is your Z coordinate. So if we had to read off the coordinates of this plane, this dot here, the first thing you do is count along the X axis, so 1, 2, 3, 4, 5 boxes, so you can see a 5 here. We go into the Y axis, 1, 2, 3, 4 boxes, that's why there's a 4 there, and then we go up here, up the Z axis, so 1, 2, 3, and that's why there's a 3 there. To look at some more examples here, we're going to have 6 shots at this. So let's look at A first. So if you're thinking about what A is, you should be thinking, right, I'll go on along the X axis first. So 1, 2, 3, 4, 5, 6, 7. Then I'll go up the Y, so 1, 2, 3, 4, 5, 6. So we've got 7, then a 6. Then you're looking along and going up on to here. So 1, 2, 3, 4. So 4. So 7, 6, 4 is what we should have there really. When we have 7, 6, 4. B, we go along X axis, so 1, 2, 3. So 3 for your X coordinate, 1, 2, 3, 4, 5 for your Y, and then 3 up for your Z. So 3, 5, 3. And you can pause these and play along yourself if you want to try them. So C, go along the X axis, 1, 2, 3, 4, 5, 6. Then in the Y axis, 1, 2, 3, 4. So 6, then a 4, and then look how far it goes up, and then a 2. 6, 4, 2. Okay, D, so that's this wee one here. So along X first, 1, 2, 3. 3 in, 1, 2, 3, and then 1 up in the Z. E, along X first, 1, 2, 3, 4, 5, 6, 7. Then we go 0 into the Y this time, so that's going to be 0. So 7 in a 0, and then how far up is it? It's 2 up. 7, 0, 2. And the last one, F, up here. So on the X axis, you don't go anywhere, so that's 0. Y axis, we go in 2, and then we go up 3 in the Z. So 0, 2, and a 3. Okay, just to finish off, we're going to look at this idea here. Shapes come up quite a lot and you have to work out what the missing coordinate is. Now quite often what they do is they don't give you the grid, so you have to work it out from other numbers. So I'm going to take the grid away here. So from this shape we need to understand that this side's 2, but that side's also 2. That's 4, so is that, and that, and that up here, so they're all 4. And this is 7, and so is that here along, and so is that dotted line at the back. So we'll just pick a few to go over. For example, if I wanted the coordinates of D I think, right, that's 0 along, it's in 2 and 0 up, so it'd be 0, 2, 0. G would be 7 along, 2 in and 4 up, so 7, 2, 4. E would be 0 along, 0 in and 4 up, because it's the same as that. So 0, 0, 4 would be E, and so on. I would advise you to practice that. It comes up quite a lot in exam questions, and it's a lead in to more difficult questions.